Hello class, and welcome to this hopefully short video describing to you assignment 6. Assignment 6 is our operator overloading assignment. It's officially available for you on Web Campus. So let's go ahead and open up this PDF and take a look. All right, so it looks like this. Got a nice little pretty picture here to show you. It's some matrix multiplication going on here. You don't have to do that, like I said in class, but if you want some extra credit, you're welcome to. I give you a nice little introduction here, which talks about why we might use operator overloading, why it's useful. So please read that. I think it's good for you. But you can come down here to the coding summary, and you can see exactly what we're working on. So you've got 3 total files. Matrix H and matrix.cpp, that's the class file or files. And then we've got main.cpp. We're kind of big coders now. You know, we're kind of past halfway the semester here. So you're responsible for coding the whole matrix class, all right? You're going to do that yourself. And don't worry, like I said, you don't have to do the matrix multiplication or transpose if that stuff is too complicated. But like I said, if you want some extra credit, you're welcome to give those a shot. All right. I would say the transpose would be some easy points. And I think the matrix multiplication will be a good way to practice for loops. All right. You're going to definitely need to know your for loops for that one. But as for the ones that you are required to do, I've listed them here. All right. And you can see that the extra credit ones are there. Now, this assignment includes stuff that we've learned before as well. You're going to have to make your own class, right? That's number 1. Number 2, there's a 2D array in there. What's that? We're using a double pointer. Oh boy, that's number 2. You've got a copy constructor in there. Kind of, that's number 3, right? So we've got some stuff going on that we've worked with before, and you're going to have to be on top of that for this assignment. So what should you do? Well, the first thing you should do is download the 3 files. And I want you to first make the class, like, you know, put that class header in the H file. Let's go kind of show you what I mean by that. I want you to come in here, look at the UML, and say, hey, let's make our matrix class here. You know, and fill in your public and private, put in the constructors, and put in all of the operators, including the friends, whichever ones you've decided to make friends, or which ones you have to make friends. Just put them all in here. And that way, you can then come into this CPP file and put in some skeleton code. So I'll give you a little example of that. Let's say I'm going to be doing this not operator, or the transpose. I would like to list that operator in this matrix class. And then when I come to the CPP file, I'm just going to put a little skeleton for it. All right, I'm not going to actually give it a body of code yet. I just wanted to have a skeleton because my main goal is to get the program to compile first before I start doing stuff with the functions and operators. All right, now for some of these things, I mentioned this, depending on what that operator or function returns, you're going to need to put in some statement here to get rid of some, say, warnings, right? Now, I'm not quite sure what I'm going to be returning just yet. So I say just return a default matrix for now. All right, and that will help get your code compiled. All right. Let's take, for example, the Boolean operator. It's going to be matrix operator equal, and then it's got some parameters in here depending on, you know, how you do it. This kind of scope resolution operator, it might not even be here either, depending on how you do it. But if you want to get this to compile, you're going to want to put at least a return false in there. Right? And then come back later. Come back at a later time and actually do the code for this. So I want you to make a skeleton in the CPP file, and I want you to make the complete matrix class in the H file. Now, once you're finished with that, you should see all of this red stuff in the main file go away. Right? the first thing that will go away is, oh, now I can see a definition for my matrix. The next thing here is put in the parameter constructor. That red will go away. Put in the insertion operator. That will go away. So on and so forth. So once you see all the red in here disappear, your skeleton is probably complete, and your code will most likely compile. All right. Now, before you get started, I kind of put a note in here. You should probably start with these 4 things: the default constructor, the destructor, the insertion operator, and the extraction operator. Now, the reason for that is we kind of need these things in order to test our other things, right? You're going to need this insertion operator in order to print a matrix to verify that it actually has the values that we care about. As for the extraction operator, we're going to need that to be able to put values into our matrix, all right? So you need that as well. You're going to need a default constructor because we're going to have to create matrices, and you need a destructor so that you're hopefully not messing with your RAM too much, right? Every time you test this, notice we create a matrix object, and then right here the destructor gets called. You're going to have a whole lot of memory leaks if you don't have that destructor, right? So once you finish that, so you'll have your skeleton, you'll have at least filled in those 4 constructor, destructor, and the global operator overloads. You can then kind of go one by one and test your stuff. Go ahead, work on that parameter constructor. Then you can do the assignment operator overload, then the copy constructor, then the bracket, so on and so forth. Now I'll show you how this program works in just a moment. But before we get there, I do want to point out that I've kind of commented these little bits out. If you're going to do the extra credit, you're going to want to bring this in. All right, you're going to want to bring that part in. You're also going to want to bring in down here in this switch statement. You'll see that I've commented out the extra credit portion for that. So you're going to want to bring that in as well. Very easy. Just delete that little those comments, those block comments here. Now this main is kind of designed to let you just test things one by one. All right, should be hopefully pretty easy for you to kind of work with this and see if things work or not. Of course, you're welcome to come in here and edit this, change it up if you need. You say, well, I really want to test it with a 2x2 matrix instead of a 6x4 matrix or a 10x10 matrix, right? Look at this here. You'll see that this is a 10x10, that's 100 cells. And then I call a C in on this, meaning you have to input 100 numbers. Now, don't worry, there's a workaround for this. I'm not going to make you sit there and type in 100 numbers, right? But I'm just saying, if you're going to make your own main file, you might want to make these numbers a little smaller. All right. So let's go look at the PDF real quick just to see if we can finish some stuff up here. I did include a note about the increment and the decrement operators like I talked about in class. We didn't quite get to those. So I just kind of want to quickly cover that stuff. So if you know these increment and decrement operators, you know that they can be meaning before. They can come before the object. So you can have plus var. You can also have minus var. Now you notice there's kind of a little space here in between these. That's not the way it should be. It's just based off of the program I used to make this PDF. If I put them right next to each other, it thinks I'm trying to make a line. So kind of in this PDF, you'll see there's like a little space there. Just forget about it and just know that those need to go side by side. Now, back on topic here. Like I said, you can have the pre's. You can also have the post, meaning it comes after the variable. It comes after the object. So that means, you got the plus here on the end or the minus here on the end. Now, when you're overloading these, you need to tell the compiler which one you're overloading. You're saying, is this the pre++ or is it the post++? And how does the compiler know which one you're talking about? Well, the pre-operators are the easiest in that they look the way you'd expect. Based off of what I taught you in class on Thursday, they follow that exact same pattern. Notice if we wanted to do a pre plus plus for our class, you have the return type here, the operator, it's the plus plus operator, and since it's a member of the class, we probably don't have to include any parameters. So notice there's no parameters supplied here. Now, if we were going to do a global operator, say minus minus, we would actually have to supply the object, right? We'd have to supply that to it, but you'll notice that it's following the same pattern that I taught you in class. Now, the tricky part is when we get to the post operators. To specify that you're working with a post operator overload, you must include a dummy integer variable in the parameters. Now, this int variable doesn't do anything. Its only purpose is to specify the difference between the pre and the post operators. So you'll notice here, if you want to compare these codes kind of side by side, I'll kind of put them here. Up here in the pre, you'll notice there's nothing in the parameters here. But over here, there's an integer in the parameters. Now this integer, like I said, it does nothing. I would not reference it. Please don't reference it. All right, don't give it a name. Don't try to do anything with it. It's only there to tell the compiler that this is the post operator, not the pre. Similarly, if we're going to do the global operator, you need to supply the object and make sure that the dummy int comes in as the last parameter. But notice that this dummy integer is supplied in both definitions here, both prototypes. So now that you know that, we can look at the UML here. It's kind of a big one, but it's the only one in the assignment. Now you'll notice I've added an operator scope here on the end. That just means some of these you don't have a choice, and some of them they're up to you, right? We know that these insertion and extraction operators have to be global, so that's what it says there. We also know that the bracket and the assignment operator have to be class members, so what's that scope? It's a class member. Other than that, the rest of these are up to you, and that's why you see some question marks here. Depending on your implementation, it'll be up to you to kind of fill in these question marks. Now, you don't have to come in here and like fill them in literally and like turn the PDF into me. No, please don't do that. Your implementation will be reflected in your code, obviously. So if you decide to make it a class member, I can see that in your code, right? You don't have to edit this PDF by any means. Now, why does the const column have some question marks? Well, some operators could be considered const, meaning they don't mutate the object that they're working with, or objects. All right, so I would say an example of that might be the plus operator. When you take int plus int, the operands are not edited. You know what I mean? They're not mutated at all. But if you take, say, this plus plus operator, the operand is mutated. So some of these operators could be const. All right, I want you to think about that. Additionally, you've got your question marks over here. Why is that? Well, if it's a member of the class, it's going to probably take less parameters than if it's a global operator overload. All right, so you're going to have to fill those in yourself, all right, in your code implementation. These last two are extra credit. That's why they're isolated down here. But they work the same way the other ones do. Nothing really different there. You can just include them to start and then decide if you want to work on them later. It's really not a big deal. This little paragraph here tells you how to read the UML up there. I tell you how much the assignment's worth. I'll give you 10 points extra credit for the multiplication and 5 points extra credit for the transpose. And then we go through each thing like I always do, right? Here's your double pointer to hold in the matrix. Here's your width and height. Now, given our kind of mess up from the last assignment, I've specified the x comes first and the y goes second, where x is the width and y is the height. All right, so make sure that your assignment follows that. So, come through here and read all these. I'm not going to read them for you. For some of these, I have included a little example for you to see what's going on here, so you can really see how it works. If you've never added two matrices before, I don't know why you wouldn't have done that. Maybe you didn't do it in high school or in college, but if you haven't done it before, I've given you an example so you can see how it works. Obviously, the easy operators are very straightforward, right? You take 1 plus 2 and that becomes 3. You take 2 plus 7 and that becomes 9, right? It's pretty simple what's going on here. Similarly with the subtraction operator, even with the plus plus and the minus minus operators, I've given you the example. Now these increment and decrement operators are meant to mimic that of the integer operator, in that the pre-increment is going to return the matrix after it's been incremented. And to show you how that works, I've said matrix M3 is equal to plus plus M1. And you can see that M3 is a copy of M1 after. If you come look at the post operators, it's the other way around, right? You'll see that matrix M3 is assigned to the value of this increment, but you'll notice the value of M3 is a copy of M1 before it was incremented. Yet M1 is still being modified. All right, so these kind of mimic how they work with actual integers. But I've given you the example so you can see it. Now this quality operator, that one's pretty straightforward. Same with the not equals. I do make a little note here. If you implement this one becomes 10 times easier. You can literally one line code this operator if you've done this one. All right, and vice versa. So, you know, don't be scared to reuse operators. Even for these ones, I'm not going to lie. You can reuse the pre-increments in the post-increment. You really could do it if you wanted to. So, you know, don't be shy to kind of use these operators to the best of your ability. You know, I showed you in class with the copy constructor, you can call the assignment operator overload from that constructor. So don't be afraid to kind of get down and dirty with calling your own operators here, okay? Now, here's the insertion operator and the extraction operator. I'm giving you the example. Just make sure that the format is correct and that you're printing it row by row, all right? You're going to have to make sure your width and your height are in proper places. I tell you how extra credit works. Now, I expect you to know matrix multiplication. If you don't know how it works, please go research it on your own. But if you've learned it before and you just don't quite remember, this little picture here and kind of these comments I've typed may help remind you what's going on. Okay? So, but please, you know, do your own research if you want to know how to do this. The reason this is worth 10 points is that you're going to have to be good at your for loops. You're going to have to be a for loop warrior for this one, all right? So show me that you know what you're doing with your for loops if you want to do that one. The transpose, I think, should be free points, honestly. But you should know what transpose is, and I do describe it to you here. Compile your code like normal. Run it like normal. Now, like I said previously in the assignment, there's like some stuff here, right? Where there's like 100 numbers that you have to enter. Now, I've provided a workaround for you. I've actually supplied input files, and you could use Linux redirection to supply, the input via a text file. So I've already supplied these for you, and I'd recommend using them unless you're going to be doing your own main file. All right, so I'll kind of run that for you and show you what it looks like. But lastly, make sure you're doing val grind at least once, because you're going to be working with memory here. You've got a pointer in there, and you're going to lose 30% of the points if you've got any memory issues. It's about time that we really know what's going on with these pointers, so make sure that you val grind it and figure out your issues. Submitting your code to CodeGrade, as always, the extra credit portion is a separate assignment, all right? So you'll see both of them there. The extra credit is a separate assignment. I will not manually check your code this time. I usually do that because of how nice this program works, in that I can kind of control parts of the program by using this input. The code grade is kind of designed to be able to give you a significant amount of points. Like, let's say for all of these, you were only able, you got all of them working except for maybe one. The way that the program is implemented, you should be able to get at least 60% of the points. All right. So make sure that you get this right. Ask me questions if you need, okay? I'm not going to manually check your code for this one. I too am a busy guy, and I don't always have time to do that. So make sure you get on top of this assignment. Whatever you submit to code grade, that's your final grade, and that's that. So let's go ahead and take a look at the code, all right? So this one is pretty simple, all right? So compile it like normal. And then when you run it, you can just run it like normal, and you're presented with the menu, all right? Now at this point, you're expected to have at least these 4 things working, all right? Once you do the skeleton, make sure you get those 4 things working to start. Otherwise, you really have nowhere to go. You need a default constructor to be able to create matrix objects. You need a destructor to avoid memory leaks. You need an insertion operator to be able to print the matrix. And you need the extraction operator to be able to give a matrix values. So at least get those working to start. Now once you've done that, you can kind of, click on some of these. Just type 1. Now I've already done this one for you. You'll notice that I'm just testing your parameter constructor here. That one's pretty easy. Some of them are, you just press 7 and it does the test for you. But other ones are going to expect some input. So let me go pick one specifically that doesn't take a whole lot. See, if I type 4 here, I'm going to have to enter 100 numbers. I really don't want to do that. But maybe I can pick this one, case number, let's see here. How about this one, 9? That's only going to expect 4 numbers for input. So say I type number 9. And now it's waiting for me to give a matrix values. So 2, 3, 4, and 5. And you'll see that I've created this matrix here. And then I tested whatever the operator was. Now, let's go ahead and exit out of this. And you say, well, I want to test the bigger one. Well, that's why we have these input files. I've given them to you. They are on Web Campus. So all you have to do is go find that input files. They're all here, and they all run a specific test. And there's even one, there's even one that runs the whole thing. And so if I just want to supply that input to the code, I can run /a.out, type a little arrow here, and then type in the name of the file that you want to test. So I'll do, say, the multiplication one.txt. It will completely supply the input. You won't see it, all right? Because via Linux redirection, you are not inputting it. It's rather being consumed from an input file. So you're not going to see it get input, similar to how it is on CodeGrade. But you'll see the results of the multiplication are printed here. All right? And in the program ended. The way that those input files work is it will do one kind of full program run. So now I want to test my bracket operator. Well, I'll just supply the bracket. Look how fast that was. Now this was the 100 by 100 matrix. All right? And look, I didn't have to type in any of those numbers. In fact, they are just there. You can go look at the input file there, and what do you know? I've given you all of the input, 100 numbers. Wouldn't you believe it? And if you kind of look here, you'll notice up top I type 4. That is to select the bracket operator. And down here at the bottom I type 0. That is to exit the program. If you really wanted to, you could come in here and copy these values. You can then come back and just run it like normal. Select 4. Now it's going to wait for your input. Paste it all. Enter. And what do you know? It does the same test. And now you can continue on if you want. Type, 1 and do it again. So that's how I expect you to run the program. It's just there to help you test your stuff. And that's the assignment. I hope you have fun with it. Ask me questions if you need. You've got a week to do it. And let me know if you've got any questions. I'll see you guys on Tuesday.